Now that your first lab exam is out of the way, we'll be going over how to do simple part assemblies. Thus far we've just been making single parts at a time. There were single pieces of geometry, a single body that could not move in relation to itself. All the extrusions, revolves, all became one piece of material, one piece of metal. Assemblies are different in that the different pieces can move in relation to one another. It's just the difference between a car part and the entire car. The drive shaft moves in relation to the frame, the crankshaft moves in relation to the block, so on and so forth. That's the big difference. A crankshaft is a part. I mean, the engine itself is obviously an assembly, with the bearings and everything else moving in relation to one another. So this week we'll be going on to just the basics of how to assemble different parts that have been made to fit together into an assembly. We'll also be going over one advanced feature just to kind of make it a little bit more interesting, is how to do gears. So the part we'll be doing this week is just inserting some gear bosses to hold our gears of proper dimensions from each other. You'll find that the plate has 3 different shaped holes. It's like a children's toy. You know, the circle goes in the circular hole, the square goes in the square hole, and the whatever shape that is goes in the corresponding hole as well. So, and then the gears fit on top and they spin nicely. We'll show you how to establish a gear relation between parts, so you can actually show some mechanisms. SolidWorks is actually fairly advanced. It'll do gears, worm gears. It'll do U-joints and all sorts of other simple mechanical type of relations and assemblies. So we'll go over some of the basics of this, but no reason to open that up yet. So whenever you are just getting into SolidWorks and you want to create an assembly, you can just go to File, New, and you'll be able to just click on Assembly. Before we've been working in parts. That's where you go if you want to make a single piece of solid geometry, but we want to work in assemblies now. Brings you up into this mode, and the first thing it puts up is, it says Begin Assembly. This is actually in your Insert Component menu. It assumes the first thing you want to do in an assembly is to enter in a component, because obviously an assembly of nothing is kind of useless. So let's go to Browse here under the Part Assembly to insert. And then from all the files we've downloaded from the OC, these should be posted in one big zip file under SolidWorks Assemblies 1 Week 5. We'll open up baseplate.solidpart. You can see this automatically snaps to my cursor. I'm free to kind of move it around a little bit, but as soon as I click, it snaps down. Now we have this part. It just looks as it does in part mode. We can rotate it the same ways. We can zoom in, zoom out, pan right, left, or rotate it by holding down Alt. Everything's the same as thus far until you notice that over in the tree on the left side, if we expand this a little bit, you'll see that we have the assembly as the top object, and now instead of having parts or operations, 3D operations, we're actually inserting parts here down beneath it. So you have an assembly with its own front, top, and right-handed plane. These are assembly planes, not part planes. You'll note that the origin of the assembly is very different than the origin of the part. These 2 dots. This corresponds to the origin of the part. The origin of the assembly is all the way over here. There's no guarantee those are going to be geometrically related in a standard sense at all. The assembly origin, the assembly basic planes can be very, very different than the part basic planes. As you can see here, when we highlight the part planes and then the assembly planes, you have very, very different sets of reference planes, default reference planes. You'll note that the first part that you insert will be fixed. There's no other real reference to the assembly. It does have its own front, top, and right-handed plane, but whenever you insert the first part, it'll be fixed in space, and that kind of establishes the ground, the earth, the reference point for everything else in the assembly that's going to be referenced onto it. Something has to be fixed. Not everything can be moving, or else it would just be a mess. First thing to learn about assemblies is the Insert Component button. If you just check this box, or click the box, you'll be able to open up a document. We'll go to the Browse menu, and let's just insert Peg 1. It'll be something default. In fact, you see this is the interestingly shaped one. We've got our offset to keep the gears spaced away from this basic base plate. And now we can go in here. Well, you say, well, that's nice. It's in the assembly, but obviously in the wrong orientation, the wrong position, not where we want it to be. So what we need to do is establish some relations between the 2 parts to position them properly. These are called mating relations in SolidWorks, and they're established by clicking on the Mate Paperclip button. Really, you'll always just select surfaces, axes, or similar parts of 2 different, or similar features of 2 different parts to put them in relation to one another. So the simplest thing to do would be a coincident relation, where this face corresponds to the interior face of this part. So you just click on the two of them, and SOLIDWORKS automatically lines them up. You see that it has mated those two faces right against one another. If we want to flip the alignment, you have the mate alignment buttons you can do over here. So that just flips the whole part around, inverting it in the process. SOLIDWORKS just flips them back and forth. But that's the correct orientation for those two faces. You see that we're actually using the coincident relation in this case. We can just establish a parallel relation, which would let us, if we actually accepted that, it lets us move this part around, but knows that that face always stays parallel to the one it's established in relation to. But see, the problem is now I've accepted a relation that, or a mating condition that I don't care for. So I want to close out of this mating tool. As soon as you click the checkbox, it assumes you want more, so you have to actually click close. You can go down here to the mates drop-down box of the assembly top tree. You can see that the parallel constraint that we created is in the tree. And just like everything else, if you right-click on it and go to the top left icon, say Edit Feature, and it brings you back up into that tool. Well, I don't want it to be parallel constraint. I actually do want it to be coincident. So click back on the button. You saw that it moved back to coincident when I clicked it, and you're good to go. Just click the checkbox. You're fine. And we can actually go on proceeding to make the other mating constraints. I want this face to be coincident with that face. See, SOLIDWORKS agrees that those two mating constraints are amenable. You can create constraints that are impossible to solve. Like say I wanted to put this face, which I've already got a mating constraint attached to, or let's do this that face to the side of this part. You see that we get an error message saying that the default mate type coincident would overdefine the assembly. That's basically saying you have a conflict. One of these previously established mating constraints that you made doesn't allow that to happen. You cannot have this face coincident with that face at the same time having the top of this circle coincident with the side of the part, because that just geometrically won't work. SOLIDWORKS recognizes the conflict and tells you can't do it. So we'll just delete those two selections. We'll do something that makes more sense, just saying that we want the bottom of this part in line with the bottom of that piece, and you can see it finally puts the part right where we need it to be into the slot, and we've essentially connected the first part of our child's toy like game. So just say OK to the box. We're done with that mating tool. This part is now fully constrained. You can see that it's actually the icon shifts here on the left of the tree to this, looks like a graduation cap. Anyway, that black icon right there next to peg 1 indicates that it is fully constrained. So let's go ahead and bring in our next component. Our next component will be peg 2. A very similar thing. You note that whenever you bring in a component, it floats with your cursor. Move it wherever you like. I'll just go ahead and click it somewhere. This one's already in a pretty close to the alignment we need. Click the mating tool. That circle against that face. You can see it automatically lines it up. Alternatively, if I didn't want to do that, there's another method. We can go up here to View, and turn on Temporary Axes. Then now you see this lets you view the axis of the hole in the main body assembly as well as the axis of these three cylinders. We can actually just click on those axes instead of clicking on the surfaces of the hole. Sometimes this is preferable if you're going to be changing the diameter of the holes. Quite often. Just establish relation between these two axes, snaps towards one another, and we're good on that constraint. We'll click OK. The next thing we want to do is make sure that the bottom of this part is aligned with the bottom of the assembly, and we're OK there as well. Now those of you will note that we only have two constraints. We've not done anything rotationally. So right now, if you could indicate, if you see that because of the geometric aliasing, the part is actually able to rotate. We've established that the axes are collinear. We've established that the bottom of the part should be flush with the bottom of this plate. There's nothing keeping this thing from rotating at all. In fact, there's not a flat face on this shaft to establish any sort of anti-rotational constraint. If it was a flat face, we could establish an angular constraint between the flat face of this cylinder and the flat face of the part, but no such thing exists. So what we need to do is go back into mating constraints. When you click on this part and the base, we can create a lock constraint, where this just keeps them from moving in relation to one another. Create that. You notice we didn't get any errors, and now if we zoom back in, we try to rotate it, and it won't. So those two parts are locked together. They're geometrically constrained to be locked in that position in reference to one another. So that's kind of handy whenever, like I said, you don't have a flat face to establish a anti-rotation constraint for. And finally, we'll put in the third block by going into Insert Components, just as we did before. Browse for the part we want to bring in. We're at peg 3 now. I'll just click that into the assembly anywhere. Notice it's rectangular, so we'll get this lined up right. This side is actually going to be coincident with that face. We'll say OK to that mating constraint. This side is going to be coincident to that face. Again, you see they lined up. SOLIDWORKS kind of slides apart where it needs to be. Say OK. And then the bottom of the peg will be flush with the bottom of the board. See, now we've positioned all three pegs right where they should be. So that is fairly simple. It's just a matter of creating coincident constraints and one locking constraint between the round peg and the bottom block. And now we have these offset bosses that we can bring in our gears to set on top of. So now we want to bring in our gear component. Again, we've downloaded that from the OC called basicgear.solidPart. We can bring it in. You notice that since we have temporary axes turned on, which if you missed it before, you enable by going to View, Temporary Axes. You can see we have the box checked. We turn it off, back on. You see it adds, since these are cylindrical gear teeth, it does have a true axis on each gear tooth. So what we want to do is, again, create a mating constraint between the central axis of this gear. And we'll just go ahead and put it on this post, the central axis of the post. SOLIDWORKS automatically aligns them. If we look straight down above, we see that it does in fact make sense. We'll accept that mating constraint. And then we will, I'll just click on the bottom surface of this, and then click on the part. So what do you do if you establish a constraint incorrectly? You see that SOLIDWORKS accepted the constraint because it's not necessarily looking at geometric interference at this point, although that is possible. We'll cover it next week. It has created an interference between these two parts because obviously the half-inch hole in the gear is not going to fit around the 0.75-inch offset boss. But we've already accepted the mating constraint. We can close it out. We could go back through this entire list of constraints and find the one that we need. You know, that's not it. This isn't it. It gets really annoying, especially in parts where you might have hundreds of relations and constraints in an assembly. So let's instead just right-click on this part. And if you notice, you have this on the top row. Second from the right, you have this paper clip with eyeglasses on it. You can click on View Mates. This shows you all the mating constraints that apply to that gear part. We created the first one where the axes are coincident. Created the second one where the two faces are coincident. So that's one we want to edit. We could just click on this and delete it by pressing the delete key. It says, do you really want to delete this coincident constraint? I can say yes or no. In this case, I'm going to say no because I just want to go in and modify it. So highlighting coincident 13, right click, go up to edit feature. And that brings us right to where we were when we established the constraint. We don't want to click on that face of the peg, so we delete that from the constraint window. We actually want it to be this face of the peg. Now you see the gear moves up to the proper surface. We'll accept that checkbox. The mating constraint is again valid. Let's say we didn't want to put it directly on that surface, because right now they have 0 inches of spacing between them. So it's a perfect tolerance, perfectly flat surfaces. Let's say for whatever reason we want 1/8 of an inch between. We can go back into this coincident constraint, edit again. Instead of coincident, we can do a dimensional constraint, which is down here, distance. You can do angular constraints, which doesn't really apply in this circumstance, but distance one does. So we can do 0.125 inches. You can see it's offset by 1/8 of an inch now. In fact, if we wanted to, we can flip that flip that constraint. It flips the gear over. Flip dimension, and it'll actually do it the opposite direction. So you have those two different things. This one flips the part. You see this window comes up, says the alignment of other mates has been flipped to prevent mating errors. As we noted before, you can create impossible mating situations. So that SOLIDWORKS actually corrects some of them intelligently to prevent a whole lot of errors from showing up. But anyway, this is the orientation we want. We want that a little bit offset. In fact, we in truth want just a coincident, but that's how you do offset relations. You can make this any dimension you want. 0.5 inches stands it off even more. Flipping the dimension moves that like essentially negative 0.5 inches, because if you note, this doesn't let you enter negative numbers. It has to be between 0 and a positive. It has to be a positive number in this box. So that's why they have the flip dimension checkbox there. But in reality, we just want coincident, so we'll go back to that constraint. That's how we want it. So we click OK. We're done with that tool. We can now close out of this basic gear 1 constraint menu. We're good to go. Again, if you need to change constraints on any part, just right click on the part, either here in 3 dimensions or in the tree. You can go in here, right click on it and view mates, Or if you want to, you can just go hunting and searching through the entire list of mates here at the bottom, which I'll hide by clicking the little expansion button on the side of it. So, moving on, we need to bring in the other two gears and put them on the posts. I will just do this without too much commentary, so we'll get through it. Bring in basic gear, just click down anywhere. I'll establish a mating constraint between the axis of the gear and the axis of its mount. You can see that SOLIDWORKS moves them over one another. I know I've done that correctly in this sense, so I'll click OK. The next mating constraint will be between the bottom of that gear and this surface of that post. Click OK. Now I need to bring in, I'm done with that, so I'll click X on the mating tool since it automatically assumes I'm going to put in more mating relations. It doesn't. Browse again, bring in the same basic gear once more. Interestingly enough, if you don't want to just open up the part over and over again, I'm going to go ahead and delete that third one. You can hold down Control, click and drag on one of these parts, and it will create a new instance of it. So if you have something you're going to duplicate, say a screw, you need to put 300 of them into an assembly, this will save you some time. Just click on the part you want to duplicate, or hold down Control while dragging it, and it creates a new one. Obviously I don't want two base plates, so I'll delete that. Yes, but I do want another gear. So mating constraint between the gear's axis and the axis of the boss. Click OK. Then again the bottom surface and the surface of this post. So we say we're good. Now I've got everything constrained, and well, if we turn one of these gears, well, nothing happens. Great. Because SOLIDWORKS by default in assembly mode does not do interference or collision detection or interference detection. It does have methods for doing that, which we'll cover next week. This is not just that's not a basic assembly type tool, but we can, in this circumstance, establish a relation between these two parts to tell SOLIDWORKS that they are gears, to tell them that the ratio with which they should move to one another. So we'll do that now. If you want to go back to the mating tool, you notice that we've just been doing the standard mates: coincident, parallel, perpendicular, tangent, concentric, lock, distance, and angular mating alignments. It's basically just the geometric matings. We have advanced mating, which symmetric, width, path. These we'll cover in subsequent lectures, but the one we're really looking for today is a mechanical mate to make these behave as gears, and there it is. So by default, if you just click on the mate button, it comes up under standard. Note that you have this mechanical mates drop down menu here. The arrow indicates that it'll drop down. Click on that. You have the gear mating option right there. So we'll click on gear, and then we'll go in here, and I need to make sure that I don't click on the axis of that part of the boss beneath it, because note now that the axis of the gears is perfectly aligned because we made it that way with the bosses underneath. So I'm going to go up here and suppress peg or hide peg 1, hide peg 2, and hide peg 3. I'm doing that by right clicking on the part in the tree. I had to expand this tree over here by clicking plus, right clicking on peg 1, that has the hide show option there. So now I know that I can just select the axis of these gears. So we're still inside the gear mating relation. I'll select the axis of this one, the axis of that one. You see that it even has the tooth per over diameter ratio of 0.5 on each. That should be the same number for both of them because they're the exact same gear. We'll just say OK. It accepted the mate, and we should be good to go to have these operate as gears, right? Well, kind of. You see that they are operating as gears, but we still have a problem. SOLIDWORKS doesn't care right now about the interference, so the teeth are just interfering with each other every time. It is turning together, but this is obviously not how the assembly is designed. So we need to do one other thing first. Before we even create the gear relation, we need to make sure that the gears are properly aligned. So I'm going to go ahead and go into the last, I'll just click on this, right click on the part, view mates, click on my gear mate. I'm going to go ahead and delete that. Just by pressing the delete key. Say yes, I want to delete it. Close out of this menu. Now note that if you're in that right-clicked View Mates, it only shows parts with which that gear or that part, whatever you clicked on, has mating relations to. So if you're in an assembly, all of a sudden everything disappears. Make sure that one of these little windows isn't open. If it is, close it. It all should come back. Okay, so what we could do is just go in here and kind of manually align the gears, zoom in real close, kind of rotate it, get it nice, and for visual things, for just an animation, that would work just fine. But if we want to be a little bit more professional about how these gears are aligned with one another, we can create a mating constraint between the trough of this top gear. So you can see these axes rotate. So between that line, go ahead and make sure this is open. So we selected that line, and we want to select the axis of one of the teeth of this other gear. You can see that SOLIDWORKS rotates the gears until those two axes are collinear, and we are good to go on that constraint. So we'll click OK. We come back here and try to rotate the gears, and it won't, because we've stipulated that those axes are perfectly together. If this gear rotated at all, they'd be ripped apart. So you've put in like this implicit anti-rotation constraint temporarily. That's the key. So now that we know that these gears are meshing perfectly because those two axes are aligned, we can go back in and create a mating constraint for a mechanical gear constraint. Between that axis, we've done this before. Notice that the number is the same. The tooth over diameter ratio, 0.5 on each, is good. So we'll say OK. Done. But you see, it already gave us an indication this mate is overdefining the assembly. Basically saying it's pointless to do that because you've already made it where they can't rotate. So what in the world are you doing? I only created the previous mate as a temporary thing, so that way the gears are meshed perfectly. If we go back to the coincident 27, this is one we made between the two axes. We just go back and delete it because it's without purpose now. All of a sudden we can rotate again. The gear ratio is proper, and since they rotated a ratio of 1 to 1, since they're the same gear, they mesh perfectly. Look at that. Now you've got the gears going nice. So hopefully this is straightforward. We'll do it one more time for this other gear. We'll go ahead and create a mating constraint between the axis of the trough on this gear over here and then the axis of the gear tooth on the other gear. You see they align nicely. Say OK. At this stage, they do not in fact rotate because we've established an implicit anti-rotation constraint. We'll go ahead and then create a mechanical mating constraint between a gear one, between this axis of that gear and that axis of this gear. It's telling us we have overdefined constraints, but that's fine. We'll say OK because we know we're going to go back and delete one. Just close out of that tool. We'll go back here to the coincident 28. And delete it. Say OK. And now we have a system of 3 gears that rotate with respect to one another. Now again, the only reason we went and created the mating constraint between the gear teeth and the gear troughs were that so the teeth would be perfectly aligned. SOLIDWORKS at this stage does not do any sort of collision detection. We have not turned that on yet. It does have the ability, but we'll study that next week. Right now you have to do this alignment on your own, and instead of just eyeballing it, we went ahead and created a constraint to do it mathematically. So you see these gears, you can sort of rotate them as much as you like, and they will always stay properly meshed. You can do mechanism analysis, you can do animations this way. It's actually very, very helpful. So that, if we go back in here and unhide our pegs 1, 2, and 3, here comes the third one. Now that is our assembly, and we've created constraints that allow us to rotate gears. Now to properly turn in this homework, we want to make it where we can see, or we can show that each part has been placed properly, and that's kind of hard in this view because you just kind of like get down a shallow angle to see that the pegs are in there, that they're properly aligned, but then you can't really see the gears, and it's just awkward. So why don't we try to make these parts a little bit transparent? We covered material properties in the lecture before the exam, so now we're going to cover appearances. So click on this little beach ball looking icon. You see we have the option of either setting the appearance properties of the entire basic gear part, which would affect all 3 of the basic gears we have in there, or you just select the basic gear option there. So let's do that. Give SOLIDWORKS a second, and it brings up these color image properties on the left. Most of the times I go ahead and click on advance. If you want to go straight to transparency, you can do color down here. You can make it red, you can make them yellow, green, blue, whatever you like. But I'm going to keep it as a basic, well, let's might as well make them orange. Go to illumination, go down here to transparency amount. Let's make them pretty transparent, 80%. Say OK. And now you can see it's much easier to tell that we have all these parts mounted properly. They still rotate because the graphical things we did not affect the assembly relations whatsoever. It's just purely optics. Go ahead and turn off temporary axes because that just clutters any sort of view you make. And then there we go. To actually turn in this homework, all we have to do now is go to File, Print. And then instead of going to an actual printer, we'll create on Microsoft XPS Document Writer or the PDF Creator, whichever one you choose to use. Say OK. We can save this wherever we like. I'm going to save it to my desktop. and just save as an XPS. And we're done. So you print off that file, bring it into class, and you'd be done. That's your homework.